Regents exam, Algebra 1, August 2016, problem number 11. Which function has the greatest y-intercept? In this problem, we are provided with 4 functions, each one expressed in a distinct form. We need to determine which of these functions has the greatest y-intercept. For this type of problem, we have no other choice but to systematically go through each option and make a decision only after we have analyzed all the possible answers. Let's start with the first option. Here we have f of x equals 3x. This is equivalent to y equals 3x. Recall that the equation of a line in slope-intercept form is y equals mx plus b, where m represents the slope and b represents the y-intercept. Comparing both functions, we see that f of x equals 3x has a slope of 3 and a y-intercept of 0. Alternatively, we could have figured out the y-intercept by setting x equal to 0 and simplifying the expression or solving for f of x or y. Recall that the y-intercept of a function is the point where the function crosses the y-axis and has an x-coordinate equal to 0. Taking a look at option 2, we see that we have the standard form of the equation of a line of the form ax plus by equals c. We can determine the y-intercept by rewriting the function into the slope-intercept form by solving for y. So we first subtract 2x from both sides of the equation. We then divide both sides of the equation by 3, making sure we divide both terms on the right side of the equation. Doing that, we obtain the following alternative form of the function, y equals negative 2/3 x plus 4. Comparing this function with the slope-intercept form of the equation of a line, we see that the y-intercept is equal to 4. Alternatively, we can also determine the y-intercept by setting the variable x equal to 0 and solving for y. Doing that, we also obtain 4 for the y-intercept. For option 3, we are not provided with a function, but we are provided with a description of the line. In this case, the line has a slope of 2 and passes through the point 1, negative 4. In order to determine the y-intercept, we can make use of the point-slope form of the equation of a line to do just that. The point-slope form has the following form, y minus y sub 1 equals m times the quantity x minus x sub 1, where m represents the slope and x sub 1 and y sub 1 represent the points x and y coordinates, respectively. Substituting the value for the slope for m and the points coordinates for x sub 1 and y sub 1, we obtain the following. Next, we need to solve for y and rewrite the equation in slope-intercept form. So we distribute the slope and then subtract 4 from both sides of the equation, obtaining the following function, y equals 2x minus 6. We can now clearly see that this line has a y-intercept equal to negative 6. Lastly, we need to find the y-intercept of option 4. Here, we're given a graphical form of the equation of a line. We can quickly determine the y-intercept by locating the point where the function crosses the y-axis, or in this case, f of x. Locating the point, we see that this occurs at the point 0, 5. So the y-intercept is equal to positive 5. Comparing the y-intercept of all 4 options, we see that the greatest y-intercept is 5, so option 4 is the answer.